Hi everyone! Today we're going to be genetic engineers and we're going to create a new animal species to display in the Orange County Zoo. So we have the DNA for the heads of 28 different species, the legs from 24 different species, and the tails from 25 different species. So we can combine these in any way we want to create a new species. Right, so let's say for example we want to create a new animal with a head of a cat, the legs of a raven, and a tail of a giraffe. Isn't that adorable? Now let's say we want to fill up our zoo with every possible species that we can create, given the DNA that we have. For example, going off of the first animal that we created, with the cat head, raven legs, and a giraffe tail, we can create a completely different species if we change the tail to, let's say, an elephant, for example. Although it still has the head of a cat and the legs of a raven, it's a completely different species just because it has the tail of an elephant. Now, I'm wondering, if we have 28 different heads, 24 different legs, and 25 different tails, how many ways can we combine the heads, legs, and tails to create a completely different species? In other words, how many possible combinations of heads, legs, and tails are there? So, the question we're trying to think about is, how many different combinations of heads, legs, and tails are possible? So in order to start thinking about this question, let's start with something smaller. Let's start with 2 heads, 3 legs, and 2 tails. So for this example, let's just have 2 options for heads, which would be cat or dog, 3 options for legs, which would either be raven, frog, or kangaroo, and 2 options for tails, which would be giraffe or elephant. So in this example, we can have an animal with a dog head, frog legs, and a giraffe tail, or we can even have a cat with raven legs and an elephant tail, or any other combination between heads, legs, and tails. So, how many combinations of heads, legs, and tails from this example can we have in total? A great way we can show all of our possible combinations would be to draw a tree diagram. So, with a tree diagram, we split up all of our options from each category. So starting with heads, we're going to split up between cat or dog. Then, from whatever head we choose, we can either choose from raven, frog, or kangaroo. So we're going to split it up as such. Then, from each branch, from the leg category, we can either choose from giraffe or elephant. So we're going to split it up again between the giraffe or elephant tails. So the way to read this would be to go down each line. So for example, if we wanted to create an animal with a dog head, frog legs, and a giraffe tail, we can go down the line for each category. So first we choose dog, then from dog we pick frog, then from frog we pick giraffe. So from this diagram we can clearly see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different possible combinations when we have 2 options for legs, 3 options for legs, and 2 options for tails. So, from the tree diagram, we can see that each branch from the head category has 3 branches coming out of it. So, we have a total of 6 branches for the legs. Then, from each branch of the legs, we have 2 branches for tails coming out, representing each of our 2 options. So, we have a total of 12 branches at the end. So, in other words, the total number of possible combinations is 2 times 3 times 2, or the number of options we have from each category multiplied together.